All right, so this is going to be the LEAP 2025 Algebra 1 practice test, session 1A. So there is your login, your URL. The username is alg1. The password is teach2025, all lowercase. When you click sign in, just click through all of this and go to session 1A. So because I'm trying to record this video and I need to be able to write on the screen, I'm going to be flipping back and forth between the flip chart and the online test to enter it on the online test. But question number 1 says determine all zeros for the function, and it gives us 2 factors. One's a trinomial, one's a binomial. So that means we're going to end up, since this is x squared, we'll have 2 answers here, and this is an x, we'll have 1 answer there. For it to be 0, what we're going to do is set each part equal to 0. So I'm going to make x squared plus 2x minus 8 equals 0. And then I'm also going to do the x minus 6 equals 0. So I want to take care of both of those factors. This first trinomial needs to be factored into the product of 2 binomials. So in factoring, I know that to get x squared, it's x times x. I know that my last 2 numbers will multiply to -8. That tells me one's positives, one's negative. I need 2 numbers that multiply to -8 and that are going to add to give me a positive 2. Now, because when we multiply, we get a negative, I know one number is positive, one number is negative, which means the different signs will actually make it subtract. So I'm looking for 2 numbers that multiply to -8 and subtract to positive 2. Positive 4 times -2 equals -8, and positive 4 plus -2 gives me a positive 2 when I add them. So the plus is going to go with the 4, the 2 is going to go with the minus. Now I break each of these factors apart. X plus 4 equals 0, and I'm also going to do x minus 2 equals 0, and I still have my x minus 6 equals 0. To solve for 0, ask what's happening to x. We're adding 4. Let's do the opposite and subtract 4 on both sides. We get a -4. To solve for x, the opposite of subtracting 2 is to add 2. So I get that x is also 2. The opposite of subtracting 6 is add 6. So x is also 6. So my answers are -4, 2, and 6. Let's go back to our test. I'm going to drive that -4, that 2, and that 6 into my answer box. Question number 2 says to graph the solution set of 2x plus y is greater than 6. All right, in order to graph this, what I'm going to do, there's a couple ways you can do this. You can use intercepts, you can use slope-intercept form. The second video that David Lemons made that I put in the Google Classroom shows using the intercept, so I'm going to use slope-intercept form. Slope-intercept form is y equals mx plus b. So I need to rearrange the 2x plus y is greater than 6 so that the y is alone. I see that the y, we're adding 2x. I'm going to subtract 2x from both sides. So y will be greater than -2x plus 6. My m is my slope. So the slope is -2, and I'm going to write that as a fraction. Slope is talking about your change in y. The words you use is rise, and over the change in x, which is your run. My b is my y-intercept of 6. So if I'm going to graph this, I'm going to go up to the 6, then use my slope and step down 2 over 1 to get my line. Okay, so that's how the line's going to be, but we need to make sure that you know how to do this on the test site. So let's go back to that test. I know it says to select the line button by choosing the line style on the graph. Because my inequality is a greater than but not equal to, I'm going to use a dotted line. It says to click on the point on the line and drag to another point on the line. So if you go back and look at this, one of the points was 6. That's my y-intercept. And I'm going to drag it to where it's down 2 over 1 and goes through this ordered pair, which is 1, 4. So on the test, you've got your line type. Hold the button down at the 6. We go down 2 over 1 and release. The next part says to select the shaded button and click where you want it to shade. Greater than, y is greater than this, is going to shade above. You can also use a test point. Whatever ordered pair is in the shaded region is a solution and will give you a true statement. If it's not in the region, if it's down here, then it will give you a false statement. If I test it 0, 0, if I put 0 in place of x and 0 in place of y, I get that 0 is greater than 6, which is false. So I know that 0, 0 should not be shaded. Question 3, which expression is equivalent to this? So for question 3, what we need to do is distribute this negative sign that is in front of these parentheses. So this is going to go to both of those. Basically what happens is that everything in the parentheses after that negative sign changes signs. So the 7x squared becomes a negative and the 6x cubed becomes a positive. Now I need to see if I can simplify it by combining like terms. I see that I have 2x cubed. So 3x to the 5th stays. When I add the coefficient 8 plus 6, I get 14x cubed. And I can't forget my minus 7x squared. So the answer is C. Let's go back to our test. Click on the answer of C. Question number 4. Which graph best represents the solution to the system of inequalities? Once again, I'm going to use slope-intercept form. I'm going to change this first equation here. I want to make it so that the y is alone. I want it to look as y equals mx plus b to graph. I will subtract an x on both sides and get that y is less than or equal to negative x plus 6. That gives me a slope of -1, and my y-intercept is 6. So I know that I go up to the 6 to start. This is not it. Up to the 6 to start, not it. This one's it. This one could be it. Okay? Now, down 1 over 1, I see they're counting by 2, so I could also think of that as down 2 over 2. So I see that this line is right, and down 2 over 2, this line is right as well. I know that it needs to be shaded below. So basically my line's good there. I need to find out about this second inequality. X plus 2y is less than or equal to 8. I'm going to subtract an x on both sides. 2y is less than or equal to negative x plus 8, and divide each thing by 2. I get that y is less than or equal to -1/2 x plus 4. So my y-intercept should be at the 4, which this is not. So this one is the correct solution, D. Question 5, let A represent a non-zero rational number and B is an irrational number. Which expression could represent a rational number? Let's go to that on this flip chart here. All right, when it doesn't give you a specific number but just says that it's rational or irrational, let's think of some examples. A rational number is any number that can be written as a fraction, including a terminating or repeating decimal. I'm going to use something easy like 5. An irrational number is a number that does not terminate or repeat decimal, but it's a decimal that goes on forever. Examples would be pi or a square root of some number that's not a perfect square, like square root of 2. Let's use square root of 2 for this problem. Which could represent a rational number? If I took my b, which is square root of 2, and change to a negative in front of it, is that still going to be, is it going to be rational or will it still be irrational? It's still going to be irrational. And I'm going to abbreviate here. Sorry for the interruption. So we have that the negative of square root of 2 is also irrational. If I took a plus b, 5 plus square root of 2, that's still going to give me an irrational number. If I did 5 times the square root of 2, it's still irrational. But this last one, which by process of elimination we know is right, if I took the square root of 2 and squared it, because square roots and squaring are inverse operations, they undo each other, what that would do is take that radical away and I would just get 2, which is a rational number. So in our test, for this part, we're going to put D. Now it says consider a quadratic equation with integer coefficients with 2 distinct zeros. If one zero is irrational, what statement is true about the other zero? I want you to think back to when we did like the quadratic formula. We were looking at a quadratic. Remember, quadratic forms a parabola. Looks like this, okay? And remember, we had 2 solutions, 2 distinct zeros. The zeros are the solutions. It's when the function value is 0, the y value is 0. When it says one of them is irrational, let's just use the numbers we used above. So remember when we did the quadratic formula, we ended up like something like 5 plus or minus the square root of 2. So this answer would be 5 plus square root of 2. This one would be like 5 minus square root of 2. Okay, this graph is not really accurate. I'm just putting numbers up there and just trying to make you understand that if one of them is irrational, the other zero will also be irrational. So option B is correct. Question 6. The figure shows a graph of the function f of x in the coordinate plane. A second function g is defined by the equation g of x equals negative 3x plus 2. Select the correct phase for each drop-down menu to complete the sentences. So I want to look and see. My drop-down menu says is less than, is greater than, or is equal to for both of these. So let's go figure out what the answer is on this flip chart. F of 2 means I'm evaluating this graph when the x value is 2. So think about the fact that since it says f of x and I'm trying f of 2, that means when my input or x value is 2, what is the output? It would be 8. So I know that this value is 8. G of 2, to find G of 2, what I'm going to do is use this equation, and everywhere there's an x, I'm going to put a 2. Negative 3 times 2 plus 2 gives me a negative 6 plus 2, which equals negative 4. So this would be 8 is greater than. The second question is saying, what about f of negative 2 and g of negative 2? I go to where my x is negative 2. I see that my y value is 0, so this would be a 0. For g of negative 2, where that x is, I'm going to put a negative 2. Negative 3 times negative 2 is positive 6. Positive 6 plus 2 is positive 8. So this I get less than. Let's go back to our test and select those answers. This one was greater than. This one is less than. Question 7. The cost to manufacture X pair of sunglasses can be represented by this function, C of X. Select from the drop-down menus to correctly complete the statement about the function C. So in place of the X, they have a 4. X is representing the number of pairs of sunglasses. So this would be 4 sunglasses that cost $398. Keep in mind, your answer should make logical sense. So I wouldn't be able to get 398 pairs of glasses for $4. That would be completely unrealistic. So that's another way that you can make sure you're getting the right answer here. 4 glasses has a cost of $398. Question 8, a circular pool of water is shrinking as it drains. This diagram shows the shrinkage. A formula for the area A of the circular pool is given by the equation A equals pi times the difference of R and 3 squared. What is this formula for R? So basically, we don't have to worry about that picture or anything at all. All we're doing is taking this formula, A equals pi R minus 3 squared, and we're trying to solve it for R. Right now, my R is inside a grouping symbol. I leave it alone until that is alone. So I'm going to divide both sides by pi to get rid of the pi on the right side. Area divided by pi equals my R minus 3 squared. In order to get rid of the exponent of 2 on the R minus 3, I do the opposite of squaring, which is take the square root, and I must do that on both sides. So the square root of A divided by pi now equals R minus 3. When I take the square root, it cancels out that square, so I can remove those parentheses. My last step to get R alone, the opposite of subtracting 3 would be to add 3 to both sides. So I get the square root of A divided by pi plus 3 equals my R, which is option, nope, not B, my bad, C, option C. Because I wanted to make sure, just so you are aware, the reason it's not this one here is because that radical should be over the pi as well. That's why C is the correct answer. And that is the test.